talk to you guys. I think this is an interesting topic from my standpoint and an interesting group to talk to. You know, one of the ways that God has kind of wired me to experience Him and to worship Him is through science and through things that we call apologetic type things. And I think this is a group where there's other people wired that way. So it's always kind of interesting to talk to a group that are have some things in common like that. You know, as Brandon said, to look at my history a little bit, I got into geology because I've been studying rocks ever since I was a little boy, and I wanted to become a geologist about as soon as I discovered there was such a thing. So I started pretty early from that standpoint. I mean, the idea of getting paid to actually study rocks and things like that is a pretty great deal for my ideas and fits me really well. But as I said, I came to know Christ at the age of 9, and so I learned to experience God through the local church and through studying His Word, and so working that way. And from time to time, I try to figure out how to relate the science to the faith, but it wasn't always obvious how to do that, and so a lot of that had to go on to kind of the back burner. In geology, I started to take some geology courses, and my Sunday school teacher loaned me a book by John Whitcomb and Henry Morris called The Genesis Flood. And this is a Young Earth Creation book, and it tries to account for most of the geology based on Noah's flood. But it really just didn't match what I was seeing, so I was I didn't know how to relate all of that, and so that kind of went back to the back burner again. You know, fast forward to kind of 1994, and I began to have kind of a group of believers and other people from work and such would meet at our house sometimes, and we would talk about how to relate Genesis to geology and science. And we didn't come to firm conclusions, but it was an interesting exercise. And then that year, someone loaned me a book that was called Creation in Time, A Biblical and Scientific Perspective of the Creation Date Controversy. It was written by Hugh Ross, and whenever I read that book, it kind of opened up a whole new world from my standpoint, because here was kind of a kindred spirit. Here was someone that was pulling in a lot of information from science and relating it to Scripture, and that was really very encouraging to me. I continue to like the reasons to believe kind of approach. You've got a group which believe and honor the Bible, and also believe and kind of respect scientific data as well. And so that's a powerful combination from my standpoint. You have they have a concern to try to share the gospel with people that have scientific interests and scientific questions, and try to do that in kind of a loving way, and provide kind of a leadership role in terms of relating science to faith. And so I think Reasons to Believe is a great organization. Today we're going to take a look at this Texas-sized challenge to the Young Earth creation. You know, if you have a challenge that's Texas-sized, well, you know, if you're from Texas, that everything's supposed to be bigger in Texas, so therefore must be a big challenge. So that's kind of what we're going to take a look at. We'll look at some of the challenges that it provides to the biblical interpretation that's held by some of our brothers and sisters in Christ. But here's kind of what we're going to go through. This works. Is we'll look first at kind of the history of Young Earth creationism and some of the ideas of modern Young Earth creation, because it kind of helps to understand where the ideas come from. And we'll take a look at how those relate and a series of predictions that they make that affect geology. And then we'll compare those to a study area where I've done quite a bit of work, and we'll look at those in terms of rock that they consider to be deposited by Noah's flood and some of the rock after that, after the Noah's flood. And both are kind of issues from trying to relate it. And then briefly we'll take a look at kind of what happens and what the impact of that is on our faith. Now, I want to point out that there are Christians with a lot of different perspectives on this, and so this is kind of a relate. I mean, Genesis is a pretty fundamental book for all of Western culture, in fact, and also particularly Christianity. It's kind of a book that tells us, where we came from and who we are. And so when you start to the first part of it, the first chapters, it talks about creation, and there's a lot of different ideas ideas about how to interpret that. And so there's a range of ideas that goes from people who believe that the science is the whole answer. Basically, all we need is natural causes that are obviously not Christians. They're people that need to know the Lord. And then we have Christians who have a lot of different ideas, and they kind of can be split by those who believe that the earth has to be 6,000 to 12,000 years old, based on how they interpret Genesis, to those who believe that the earth is billions of years old. And again, there's still a range of ideas within that group, from those who are believing kind of theistic evolution, which is to say that God is working through natural causes, and that would include evolution, which introduces life, and also all the way up through humans. Some would say that, okay, that's not enough. Basically, there's enough signs within life to say that there had to be an intelligent designer. Some of the features of life actually involve foresight. They involve things which are saying that you had to know what you were doing and building before you could build what you got. And so that would be kind of the intelligent design community. And that is not particularly related to Genesis, but it is a popular group within this, and most of the group are Christians. And then you have a group which are called Old Earth Creationists, and Reasons to Believe is probably the leading proponent on that. And we're saying that basically God worked through billions of years to prepare Earth for man, and that God continued to take a very active role in introducing life. Dr. Ross holds a view that's referred to as the kind of day-age interpretation, saying that, God led the author of Genesis to record 7 days, 7 periods of time, which were long periods of time over which creation took place. And I point out that that's not a new view on that. But I do want to point out several times to make sure that everyone understands I'm saying that all of these people are Christians, Bible-believing, within this type of yellow circle in here. And so what we're talking about is a difference of interpretation of Scripture and a difference of interpretation of what science shows. And today we'll spend most of the time looking at that scientific evidence for that. But I want to point out from the day-age standpoint that, once geology began to show that there was more than 6,000 years, then that began to be an issue, and a lot of people had to work through that. But over time, most Christians were able to kind of fit that in and not have a problem with that. But I'll give a couple of examples of that. Reasons to Believe, as I say, it's not the first to hold to kind of a day-age Earth. In the late 1800s, these are two of the most prominent geologists at all, and both of these were committed Christians, and they both held to a day-age model, and there's publications available where they explain that, and there's a lot of similarities in what they were saying then to what we would say today with kind of a Reasons to Believe model. But although people were believing that, and last year, there's a survey comes out that says 40% of Americans would believe that God created man in their present form roughly in the past 10,000 years. So there's a substantial part of the population that have a very different understanding of science and how to interpret that. And the roots of this go back to a Seventh-day Adventist author by the name of George McGready Price. And this is a book that he published in 1913, The Fundamental of Geology, and their bearings on doctrine and of the literal creation. And Price was a very prolific writer, prolific speaker, and he put together a lot of ideas, many of which are held by Young Earth Creationists today, although some have kind of gone away, and even Young Earth Creationists don't hold to them today. But some of the arguments which he pointed out, geology geologists at the time didn't have great answers for, because at the time there was no plate tectonics, and there's been certainly a lot understood or learned over the last 100 years. But still, this was sort of a fringe movement, partly probably because it came out of the Seventh-day Adventists. So it wasn't very, very popular. If we go forward to 1955, there was a guy named Bernard Ram, who was a Baptist theologian, puts out a book called The Christian View of Science and Scripture. And he was saying that basically science and scripture are not enemies, and they can work together. His particular view was called a progressive creationism, so that he felt that creation took place over many separate interventions by God, but that sequence of events took place over a long, long period of time. And this was influential. And Billy Graham came forward saying that, hey, this is making sense. Rand is showing a good way forward. But it had another consequence, that the fundamentalists were not happy with it. And two of those were John Whitcomb and Henry Morris, the authors of the books that I was given in college, and it was hugely influential. And Young Earth Creationists, modern Young Earth Creationists, kind of all tie back to and consider this kind of the linchpin of their movement. And it's called the Genesis Flood, the biblical record and its scientific implications. John Whitcomb was a scholar. Henry Morris was a hydraulic engineer, university professor from the University of Oklahoma. And, you know, they made this sound fairly scientific. It had footnotes, and it was gave a lot of people who wanted to believe this type of thing a basis for looking at that. They said, hey, this is something that this is a scientific account that's following the Bible. So that was very, very popular. Henry Morris designated a successor to write a sequel to this, and that was a man by the name of Andrew Snelling. Andrew is a creation geologist. He has a PhD from the University of Sydney, and he's with the Director of Research and Answers in Genesis from Ken Ham. The books are kind of two volumes called Earth's Catastrophic Past. Volume 1 basically is the scriptural interpretation. Volume 2 tries to relate or explain the scientific basis that they have. And they're saying that basically it's not just that they believe that the biblical interpretation demands that, but they're also saying that the scientific actually supports this interpretation and shows that young Earth creations today can be, very intelligent, well-educated, and they can present their arguments in a way that those who really aren't familiar with science can be easily persuaded that it's just a matter of how you interpret the scientific data. But is it just a matter of how we interpret the data? Can we interpret the geologic data in such a way that it fits that model? This model comes with a series of kind of features that you would have to use, some predictions of what the record ought to look like. Here's a set of kind of 8 different features or different characteristics of young Earth creation, the assumptions they make that affect geology. For one, they would say that the Earth was created mature and complete, just as Adam was created in this model as a mature adult. The Earth was created mature, so it might look old and it would have the appearance of age, but it wouldn't really be old. That's the difference in maturity and age. I guess humans have that too. Sometimes we're not as, we can be a lot older than we act. The idea is that creation took place in 6 24-hour days. So that's comes out of their interpretation of Genesis 1. And the date of creation is either indicated by or at least limited by the genealogies of the Old Testament. So if you had just these genealogies, then you end up with creation in about 4,000, or as Bishop Usher said, 4004 BC. But if you have if you believe there are gaps in that, then you could make it maybe 10,000 years old. So you have a little bit of freedom that way. The picture is that life appeared in terms of plants on day 3 and day 5 for animals. So if you have fossils, then certainly they were after that. So the rock that was created mature, one would not expect to have fossils in it. And of course, there was no death prior to Adam. So again, there would not have been any fossils in the earlier rock. And then you have the idea that, of course, animal life was created as vegetarians because they didn't eat meat until after the fall. And so all carnivores had to be later. And most would believe, although some would have a little different ideas, but say that there was no rain before the flood. So there's just mist that rose up before the flood, and that was global. And of course, Noah's flood was a global event. It's global tectonic catastrophe. We can look at these and say, okay, these kind of boil down to a few specific predictions of geology. And here's 3 of these. One would say that all of the rocks were deposited since creation were deposited in just a few thousand years. So anything, particularly with fossils, everything has to happen within a few thousand years. Large amounts of rock record were deposited by a global flood, and it laid down its deposits over the course of 1 year. And everything since that has a very limited time, because the flood wouldn't have been that long ago. So these are things which we can look for in the rock record to see how they match. Is this what we actually find? If you took all of the, if at one location there was continuous sedimentation through that whole period, then you would have a stratigraphic column. It wouldn't have to be in all in one place, but it could be in other places. But in general, this was stratigraphic based on the Young Earth creation model, and there's what we see in the rock record, and we can compare those two. Looking at this, what we would say is that creation took place in 4,000, so some rock that was rock in this first area here, and number 1 would be rock that's created looking old. So this is rock that was created. And then between Adam and Noah, you have the pre-flood deposits, which would be number 2 here. Number 3 is this 1 year period in here, which is actually blue, but you can't see very well here. And that's Noah's flood. Perhaps if it's 4,000 year Earth, then that would be occurring around 2348 BC, depending on, that's kind of based on the Masoretic text. And then you have post-flood deposits. And at some point in time, it gets to where you have rock where everyone kind of understands when it was deposited, and everyone agrees, whichever model you follow, from either Young Earth creation or from a conventional geologist, we should agree on it. And where that rock begins might be debated. For instance, you might say, if you're looking at Texas, well, we know where the coastline was when the Spanish conquistadors came through. So, in the 1500s, we ought to know where it was. Maybe before the birth of Christ. But most people would agree that around 1900 to 2000 BC, around the time of Abraham, we can date rocks with pretty high confidence from that time frame. And we don't need a lot of precision for this, particularly in the study area that I'll be looking at. The answers are different enough that we know there's not a lot of rock that we're talking about, regardless of which period we're looking at. So this is what, from a Young Earth Creationist stratigraphy, would look like. Conventional geology would divide up the rock record into, like a Precambrian eon, the Phanerozoic, where you had more complex life. 3, the Paleozoic, Mesozoic, and Cenozoic. You can think of those as being pre-dinosaurs, dinosaurs, and post-dinosaurs. A series of periods and epochs after that. Now, Young Earth creationists who have studied geology tend to recognize that order of deposition is real. I mean, they have very different ideas about what processes were involved in laying the rocks down. and what time frames are involved, but they understand that the geologists have correctly described the order that rocks were in. Now, in this exhibit, the way I've put the geologic stratigraphy, I've put about the same thickness for particularly the epochs and some of the periods and stuff that way. And that's not the way that we would really date those based on conventional, well, using radiometric dating, but it kind of begs the question if I start thinking that that's true. So I've kind of taken that out by making these all about the same time range here. But geologists recognized the order of the stratigraphy a long time before radiometric dating was involved. They understood the order that rocks were formed in long before evolution was proposed. So this was not generated to support evolution. So those type of things which you read and sometimes in the literature are just wrong. The question would be, if both sides kind of accept this order of the rocks, how do you correlate the two? Well, let's see. We can look at that and we can say, well, when did creation take place? Where do we start seeing fossils? Well, there's early plant life in the Archean time, so maybe creation down in the early Archean. If you want to say more complex life, then that would be at least in the kind of late Proterozoic period there. So maybe that would be the creation time frame from a Young Earth Creationist viewpoint. Abraham can be dated to the kind of late Holocene. So in that standpoint, if we're looking at things in the Holocene, then that would be stuff that is potentially during the time of Abraham, depending on what type of assumptions we make in terms of rate and what type of rock it is. So the question would then becomes, how do you understand Noah's flood, of course, that way? Because this is was supposed to be, or is interpreted to have been, a global catastrophe. This is where you've had all kinds of earthquakes and tectonic activity, volcanic activity, dramatic erosion, dramatic deposition. You would think that this would be something that would be pretty obvious in the rock record. Unfortunately, Young Earth Creationists have some issues in trying to understand that, and that they have a lot of different interpretations of what that looked like. So in this one, what we're seeing down in the bottom for 10 different interpreters here, 11 if you take an article from last year, from 2019, you have where was creation take place? Some would say it's Archean, maybe the up into the Proterozoic, as I said, that way. Some say there's a little bit of rock that was deposited between creation and the flood. Most of the people will say that these were deposited by, and some of the authors say, particularly people like Snelling and stuff, would say were deposited after the flood. So we'll take a look at some of those type of interpretations and see how they compare. There's basically kind of a couple of issues that we have. One thing, like Kevin Nell said, a friend from Facebook who calls himself the Geo-Christian, his term is there's basically just too many events in too little time. You've got too many things that took place and too little time to explain them using this model. And we'll just see some examples of that. And sometimes it's kind of a square peg in a round hole. Just things aren't compatible. You find things that are supposed to have taken place during a big flood, but they just don't look like flood deposits to a geologist. To do that, we're going to look at one particular area on that. This is kind of where I've done my work. You can see we've got New Mexico and Texas and offshore western Gulf of Mexico and northern Mexico. This is a geologic map of it, and so that the different colorful bands in here are different ages of sedimentation, ages of rock, except out in the Gulf of Mexico where it's kind of structural regimes out in that area. And to me, it's a great area to work with. I think this is partly from my experience. I was actually born and went to undergraduate school up in kind of the in New Mexico up in here, and then I went to graduate school in El Paso, so I studied that. I did my thesis down in Mexico, down in here, so that's one reason why that's tied in, is to come down into this part. But I've worked production geology and exploration West Texas a lot of times spent in South Texas. We're looking at production geology out in there, exploration and production in the Western Gulf. So again, my experience works in that. But it also has a lot of great data sets. We're living in a great place for studying this type of thing, based on the fact that the surface geology is so well constrained. That's been worked in a lot of ways. The thing it has that some of the other areas don't have is that there's a lot of well control. You can imagine there's almost literally a million wells within this area. So that provides a lot of control. There's a lot of seismic data, which is helpful to be able to understand it. And it's very complete in terms of the rock record, because it goes all the way from the kind of Proterozoic all the way up through the Holocene, up through the recent deposits in there. I guess the only thing that's really most significant rock that's missing is kind of the lower part of the Triassic, but that's just not, the continents were high, so we don't get that type of deposition in here. So, I'm familiar with Ken Wogemuth and Greg Davidson and some of the others will work with the Grand Canyon, but I think this is a spectacular area, so I think this is a good place to work as well that way. I liked it so well that I put together a book. I had to try to document what I was learning and what I was seeing in that when I tried to have answers for people who were talking to me about the Young Earth type of model and why that was valid or not valid. And the first part of this book, the Texas Size Challenge, is basically explaining this area. Of course, the second part of it, I have to go into Genesis and try to understand what actually did take place. And because I think Genesis can and should be interpreted in a way that it doesn't conflict with the scientific data. We're going to take a look at some particular examples in here. We'll take a look out in West Texas at a cross-section in an area in here, which again, I'm pretty familiar with. This is a cross-section kind of near Midland and Monahans area. It's across a feature called the Central Basin Platform. The different colors in here are different lithologies. So the purples are dolomites, blues, stone. The yellows in here are sandstone. There's a lot of shale in it. There's some chert, but they're pretty thin at this scale. The green in here is not greenstone, but it actually is oil field, because there's a lot of nice oil out in here. I started in the oil industry. I worked summer as a roustabout for the Gulf Oil around this North Ward Estes field, just west of Monahans, and going out and looking at wells out in that area. And to me, it's a great picture. And this is kind of what it looked like at the end of the Permian time. So I'd like to step back a little bit and go back to the Pennsylvanian time. And geologists typically would say that this was around 300 million years ago. And what we see is there was an erosional unconformity that comes across. And all of this rock that was down at the base part of it was at one time laying horizontal, but now it's been tilted up, it's been faulted and folded. And that took place after the rock had already been formed as rock. In other words, this is laid down in soft sediment, and now it's been lithified into hard rocks. And this means that we can take a look at this and say that there were mountains in this area that were over a mile high that have been eroded away on this. So there's been a lot of things that have taken place. And we know it was rock because there were actually stream gravels along that unconformities that have become producing fields and that have been cored, and you have that gravel from the earlier rock forming in those. Young Earth Creationists often like to say that this was all soft muck. This was soft muds and things, and that's why it could be folded. But that's clearly not the case here. I'm going to take a look at a picture of a rock. Well, this is kind of in the Marathon region. This is kind of out along I-10. And we have Pennsylvania rocks in here that have been tilted and folded, and in this case, basically vertical. And then they're overlaid by Cretaceous rocks that are horizontal. And if you were near your geologic periods, you'd know that between these two, this unconformity in here actually represents kind of two unconformities. So we've got rock that was, or sands that were deposited in a deep water setting. They were buried and turned into rock, and then they were folded up vertically. And then there were horizontal rocks deposited on top of that, which were Permian in age. And then those have been eroded away. And then there were horizontal Cretaceous rocks laid on top of that. That's a lot of events to take place. And there's just not a lot of time to do that. Trying to do that all within Noah's flood, I think just is essentially impossible. So let's go back to the cross section now. And we're going to take a look at what it looked like later with the rock that was Permian that's laid on top of this. And the Permian rock, a lot of the top in here was laid down in arid environments. There was a deep basin over here to the west, known as the Delaware Basin. And along the margins in here, we had massive reefs that were formed. And to look at the very top reef in here, this is the Capitan Reef. And you can see that it went all around Carlsbad up through the Guadalupe Mountains and is exposed in a number of mountains. The red dots on this map are well control, so there's a lot of well control, which tells us where it is. Mainly it's not an oil field, but there's a lot of fresh water that comes out of it. And you can see the picture shows kind of what it would have looked like at the time of deposition that way. So this I'm saying was a reef, and of course today we have coral reefs such as in the Bahamas and the Great Barrier Reef in Australia. But and geologists use a lot of the reef in a lot of different ways. But from this standpoint, I'm saying that this is a concentrated accumulation of carbonate. It is it's in the form of a buildup or a mound. It's locally derived sediment, and some of the sediment is growing in place. So some of the animals or fossils were growing in place that way. And the facies that we mapped were very similar, even though the characters have changed to what we see in modern reefs. If you were to go out to West Texas, you could take a look at this rock that, as it forms, there's a stop that's near Guadalupe Peak and Capitan Peak that's made by geologists. Thousands of geologists have seen this. And you see the sediments that are dipping the basin out in here as four reef deposits that are classic reef deposits. Sandstone that was laid out in the deeper water environments this way. And so we can map the deep water deposits. We can map the reef and carbonate banks in this area. We can map backwater lagoons, algal flats, salt flats back behind that, known as sabkas. So it's a process that we kind of understand. Young Earth Creationists will tell me that this wasn't a reef. And of course they have to believe that, because if this had been a reef, it would break the model. It would not have formed in a year. It had to take place some other way. If you have any one bed or set of beds which took place took more than a year to form, then the Young Earth model wouldn't work for that way. So, but here we've got a lot of different fossils that clearly were growing in place. This wasn't some big floating mass, or this wasn't a mass transport deposit. It wasn't a coral reef. It was made up of sponges, bryozoas, algae, crinoids, lots of different types of animals, but they're not, they weren't corals, but they were still forming in a reef. And it's not the only one that forms in Texas or in the area. In this map, what I've done is I've shown the different reefs that are reef trends, that are major trends that are recognized in the area. You can see in the geologic column, they form all the way from the Cambrian all the way to the recent, and there are modern reefs growing out in the Gulf of Mexico today, and they go all the way back through time. We're looking at the Capitan Reef, which forms out in here. And I want to show a couple of examples of other types of reefs that formed. First, we'll look at some of the oldest ones, and they're the called the Point Peak algal mounds. These were little patch reefs that formed. This is near Brady, Texas. I took this picture there. The reefs in this case are made up of stromatolites that were formed before you would have had some of the other animals. Stromatolites are basically algal beds. As tides went back and forth, and the sediment would collect in among the algal deposits there, the green algae, and that formed layers. We see lots of different laminations through this. Again, lots of tidal deposits in through here. Today, they form at a rate of maybe 1 to 5 laminations or years per lamination. So trying to do that during a global flood sounds like a problem. It just didn't take place that way. It's too many events, and it's incompatible, both from that standpoint. Going to move a little bit younger than that, still younger than the Permian Reef. Go out to near Snyder, Texas, and there's a feature called the Horseshoe Atoll, buried down in the subsurface. It forms different ages within that, all within what we call the Pennsylvanian period in here. It's pretty important to Texas because there's been 2.5 billion barrels of oil that's been recovered out of that. That makes for a lot of different studies because it's a big target, and it's about 3,000 feet thick. And it's a good example where we can see where there were lots of different steps to this. Because when sea level would drop, then the reef would be exposed, and then they would develop, fresh water would leach it out, and you would have porosity developed in it. That's what holds the oil. And that's pretty nice from that standpoint. In this case, there are 20 different layers of that, which were porous limestone separated by shales. The shales were formed when the water got deeper again, and then it would start over and grow again. This didn't take place in 6,000 years, or it didn't take place in 1 year. This is incompatible. Reefs like this don't grow in a flood because a flood creates a lot of mud and a lot of things in the water that tend to kill the filter feeders that make up the reefs. A couple more examples. Looking at the Cretaceous time frame, we think people might be more familiar with the Cretaceous because they think of the T-Rex, but it also had some other things which were kind of supersized clams, which were called rudists, which formed reef trends, which wrapped all the way around the Gulf of Mexico. This is kind of the Edward Sligo trend in here. Lots of little patch reefs and small reefs over a broad area across this part. And again, they show that there was a lot of clear, warm deposition over slow time of periods of time. And they also were exposed to freshwater leaching early on because, and that's helpful to us because the Edwards Reef and Edwards Formation is the major freshwater aquifer, the largest freshwater aquifer in the state. And much as we like oil and gas, we also like to have some fresh water to drink as well. The period after that in the Cenozoic, we'll look at one little reef which formed. And because the Cenozoic period is a lot of shale and sand, mostly in offshore Texas, or onshore Texas and offshore Texas, both. But occasionally there were some little reefs that formed. Here just south of Texas, there was a little 100-foot thick coral reef. Now the corals have come in and looks very much like a modern type of reef, the same type of environments. Again, it's about 100 feet thick. So if you took modern growth rates, then you would say that took about 150 to maybe 600 years to deposit. And that's just a little tiny part of the Oligocene sediment, and certainly a tiny piece of the Cenozoic section. So it's hard to imagine that taking place either during the flood or even in the Young Earth type of model. Too many events, too little time, too much incompatibility. I'll look at one more type of sediment. Again, I'm a stratigrapher, so I like to see the type of rocks that were deposited and how they were laid down. And as I mentioned, we see indications across that central basin platform of a lot of dry environments and arid type of things. We see a lot of evaporation which took place. And we'll look at an example from up in here, which was called in an area called an Iatan Field. This was from Mitchell County, Texas. It wasn't my county, but it was I like the name of the county. What we do have is we find crystal laths, which were originally gypsum, which are now anhydrite, and these form an evaporites form where you're supplying a lot of water at times, but then it evaporates away and the overall environment is dry. We find this, which is called either spiderweb or chicken wire anhydrite, and we find anhydrite nodules. In this case, we had these stromatolites, which were forming here, which were then partly dissolved by fresh water. A storm came along, ripped up a clast, and then anhydrite. And they look very much like the type of deposits that we see today in the modern Persian Gulf, where we're seeing nodules, where we're seeing chicken wire anhydrite forming. It's pretty incompatible. If we look at the Persian Gulf today, we would see, again, the chicken wire, we would see the anhydrite nodules on these dry salt flats. And that formed over a lot of West Texas. How do we do that during a flood? That's a compatibility problem that I don't think the flood model provides an answer for. So from looking at the flood, the Young Earth Creationists have identified a lot of different deposits as being from the flood, from Noah's flood. But again, I've said there's just too many events and too little time. We've seen sediment that was buried that was turned to rock. The rock was folded up into mountains. The mountains were eroded away and buried. And we saw reefs that grew and they're dried and buried. It's just too much to have taken place during 1 year. Didn't happen that way. And it's also, there's a compatibility problem. We've got these arid deposits that just don't fit that type of flood model. So the flood model, the rock that was deposited by the flood, has a lot of issues, and then a lot more we could look at. But also the rock that's was laid down after that period of time provides a lot of problems for the flood model as well. And to look at that, we're going to take a look. This is again that geologic map, but we're going to look at this profile AA prime in here. And this is one that I've compiled from a lot of different sources. It's about 2,000 miles long. So we can think about what part of that model. This is that cross section. This rock in here is igneous and metamorphic. So it might have been in the Young Earth model as created looking mature from that standpoint. Then you have Paleozoic rocks out in the Midland Basin. There's that Central Basin platform. There's an uplift in the central part of Texas that's called the Llano uplift. But if you go around that, you find that those Cretaceous rocks go all the way across the top of that. And then you have the green Mesozoic rocks, kind of the dinosaur period in here, and the Cenozoic period in here, which some interpreters would call as post-flood deposits, and then this section here. So the question is to say, what part of this are we going to say was from the flood and what part was from after the flood? So you've got a 450-year period, basically, if we use the 6,000-year Earth between Noah's flood and the time of Abraham. So some would say that it took place again as looking at the Quaternary section up in here, kind of the base of the Pleistocene as being the top of the flood deposits. Some would say, oh no, it goes all the way back down into the Permian period. And this is a European author that I've read, named Shevin. There's also some would say is that the base of the Triassic is the top of the flood, and others would say, well, no, it's the top of the Cretaceous. So a lot of different opinions. If we go back to that cross section, you'd be saying, okay, if this rock was from creation, pretty much in these cases, then we're going to take the flood deposits, and then I have to explain all of this rock within the flood, and there's not much to account for after that. But in many cases, they're saying that there's a lot of rock after that, after the flood, that all formed in that basically 450 years. So let's take a look at what that would mean. What we have here is a map which shows a lot of the growth faulting in Texas. And in these colored areas, these are these large deltas which formed across this. Deltas take time to form. The oldest rocks, oldest deltas would be in the Cretaceous period, up in these areas. Then it gets younger as it comes out, with a series of them in the Paleocene, Eocene, all the way out through the Miocene, ones which formed originally in the Gulf of Mexico. Deltas formed all the way out, way offshore, and then they step back to the deltas that we have today. And this is a cross section which comes across here, which was done in depth. You can see on it the green kind of Cretaceous period or Mesozoic rock, and then all of this Cenozoic rock that forms in here. And these are salt masses that have been deformed and formed weird and wonderful shapes in the offshore Texas area. And we're going to zoom in on this little piece in here because we're looking to try to find when Abraham lived, the rock that was formed after Abraham. And in fact, we can find that. We can see it on this case, that there's a little wedge of sediment in here in red. And this would be rock that we can calibrate it. We know what 4,000 years of deposition at kind of normal, non-miraculous type of rates look like. So we're saying that potentially this little piece in here, which wouldn't even show up on the profile that we had, took place after Abraham, and all of this other rock took place in about 450 years. So that's pretty challenging from my standpoint. It's hard to manage that. The interpretation is that basically this took place as because the flood sediments were unconsolidated, it was very soft, and you could erode it very, very quickly. If you're going to erode and deposit rock very, very quickly, and you're going to move that amount of rock, you're going to have some huge river systems to be able to do that. 3D seismic allows us to actually image some of these type of river systems to see what they actually look like. And it kind of does away with this objection because we can actually image some of the rivers. And there are a lot of them exposed, but not many of them have made their way into the literature. These are some little river systems that are involved. And it turns out that Texas rivers have always been kind of small. I know it's nice to think that everything's bigger in Texas, but there just haven't been very big rivers in that. Most of the ancient rivers seem to be very similar size to the modern rivers that we have. So again, it just really doesn't fit the model that is proposed. We could take a look at a lot of different other examples that are conflict with this. We obviously don't have time today. We could look at subaerial volcanoes. We could look at swamp deposits and how our coals form, how long it takes to form or deposit thick shale units, paleokarsts or ancient cave systems that formed in the rocks and were buried. We see footprints that are dinosaur footprints and try to figure out how those formed during the flood. How do you form lots of different layers of soils? How does the fossils fit? The tectonic rate? A lot of things we have too many events and too little time to explain them with. So from my standpoint, the Young Earth model just doesn't fit the scientific data. It doesn't work that way. It also, I think it has big problems in terms of explaining the Bible and the scripture, but that's a different issue. And the question is, if the earth is old, what does that tell us about God? Can we learn something from that? And I'll say just briefly that if we have an ancient earth, what does that mean to us? Jeremiah declared that but God made the earth by his power. He founded the earth by his wisdom and stretched out the heavens by his understanding. Now, if we learn about the universe and the earth, that they're ancient, it does teach us something about that. But we have to listen to what it says. You know, God said, "Where were you when I laid the earth's foundation? Tell me if you understand." God's understanding is a long ways beyond ours. He understands things that we can only begin to understand, and our understanding really relates to him. We trust science because we trust God. And we've learned a lot. Copernicus kind of started the problem because he showed us that the earth wasn't the center of even our planetary system that way. You know, that we weren't maybe quite as important. If you go back to 1923, when Hubble trained his telescope out on the little hazy patch of sky called the Andromeda Nebula, it turned out that the nebula wasn't just a cloud of dust, but was actually what we know as the Andromeda Galaxy. He discovered that our Milky Way was not the universe, but just one galaxy among many. Our world became smaller, man became tinier, and the Creator really becomes greater because he was even greater than what we could have conceived of before that point in time. If we look at small things, though, it's not just the big things that way. We've learned a lot about that. At one time, the atom was supposed to be the very smallest unit of matter. But now we recognize there's 36 different subatomic particles on this. In the last 100 years, we've learned a lot about this. We've learned that God's mastery over the tiny is also very great. You know, in Darwin's day, one-celled animal cells were just blobs of protoplasm. But today we know that they're incredibly intricate, very well engineered. Designing such a system that could exist, let alone replicate, self-replicate, that's pretty amazing that way. You know, it shows us that God was not just an impersonal God, but he was very involved and intimately involved in his creation. But over the last 300 years, man has become smaller, not just in terms of his power, not just in the detail that's involved, but also in terms of the time of existence. You know, Daniel referred to Jesus as the Ancient of Days. We recognize that even in terms of our own timeline, that we're very small. Our time of life is very tiny that way. God is much greater and much vaster. His plans are much bigger than ours. And that's what's happened that way. David said, "Show me, O Lord, my life's end and the number of my days. Let me know how fleeting is my life. You have made my days but a mere handbreadth. The span of my years is as nothing before you. each man's life is but a breath. I think the geologist's understanding really helps us put that in perspective a little bit. We understand how much longer God has been around and how much longer eternity is, as he is outside of that. Now, to recognize that, I think we can look back, and if you look back at the hills of Jerusalem, you'd see that they're made up of Cretaceous limestones. And that means that around 90 million years ago, God could have looked out across that the lime muds that were forming in, knew at that point in time that someday those would harden into stone, and they would form the hills that would be Golgotha. And that on those hills that his son would die so that we might have life. And I think that helps us to appreciate God's love even more. And just to conclude, if you're interested, there's also a website I've been playing with during the COVID time, which says that Jesus is real both in history and in science. And so I've been studying a lot of different topics. I'd certainly invite you to go out and take a look at it. And I guess at that point, I would love to take questions if anybody has questions.